Welcome to definite integrals and motion. So recall that we had a relationship between position, velocity, and acceleration. So recall that if we have x of t is the position function, and v of t is velocity, and a of t is acceleration. Then we had two things. We had the derivative relationship. We had x prime of t is v of t. And then we had a second derivative of x of t is v prime of t, which is equal to a of t. And then we also had that if we took the integral of v of t dt, we're going to get back the position function, maybe with a plus c, right? And we also have, if we take the integral of the acceleration function, dt, we should get back out velocity and then plus c, right? So velocity is an antiderivative of acceleration, and position is an antiderivative of velocity. So with these relationships, we wind up getting sort of some useful things with the definite integral as well. So if we want to look at the definite integral of velocity, so let's say the definite integral from a to b of v of t dt. By the fundamental theorem of calculus, as long as we have an antiderivative, we can just use the antiderivative and subtract. So the position function is an antiderivative of velocity. So this would just be x of b minus x of a. Again, using the fact that position is an antiderivative of velocity. Once we have that, this is just the change in position from A to B. Otherwise known as the displacement from t equals A to t equals B. So if we are asked to find the displacement and we know the velocity function, all that is required is finding that definite integral of velocity. So let's suppose an object is moving along a straight line with velocity v of t equals 2t plus 5. We want to know what is the displacement over the time interval 0, 6. So all we need to do is displacement is equal to the definite integral over that time interval. So we're going to go from 0 to 6 of v of t dt, or the definite integral from 0 to 6 of 2t plus 5 dt. 2t plus 5, we know how to integrate. So 2t would go to 2t squared divided by our new power 2. And then we'd have plus 5t. And we're going to evaluate from 0 to 6. This becomes just t squared plus 5t evaluated from 0 to 6. So we are looking at 6 squared plus 5 times 6 minus 0 squared plus 5 times 0. And that's just 36 plus 30, or 66. I didn't give units. Usually we would have some units, so let's just add them in. Let's say our units were feet per second. And then the time interval is from 0 to 6 seconds. So this displacement would be in feet. So essentially what we're saying is from the time t equals 0 to time t equals 6 seconds, the sort of resulting distance traveled is 66 feet. There may have been squiggly in between, but sort of the end result is that we've traveled 66 feet from start to finish. All right, next up, let's go ahead and take a look at the definite integral of acceleration. So if we want to take the definite integral from a to b of a of t dt, velocity is an antiderivative of acceleration. So we could just use v of b minus v of a. And again, velocity is an antiderivative of acceleration. So from here, essentially what we have, this is just the change in velocity from time t equals a to t equals b. So if we were asked to find the change in velocity over a specific time interval, we just need to find the definite integral of acceleration. So for the next example, suppose an object is moving along a straight line with acceleration a of t equals 2 cosine t. Let's add some units. Let's say it's feet per second squared. And we want to know what is the change in velocity over the time interval 0 to pi over 2. So our change in velocity will be the definite integral from 0 to pi over 2 of acceleration dt, or a definite integral from 0 to pi over 2 of 2 cosine of t dt. Now, 2 comes along further right. The integral of cosine is sine. So we have 2 sine of t. And then that's evaluated from 0 to pi over 2. So we are looking at 2 times sine of pi over 2 minus 2 times sine of 0. Sine of pi over 2 is 1. So this is just 2 times 1. And then sine of 0 is 0. So we have 2 times 0, and we wind up just with 2. And then this is velocity, so it'll be 2 feet per second. So essentially, the change in velocity is 2 feet per second. The initial velocity and final velocity, we don't know precisely due to the constant when we integrate, but we do know at least the difference between them. So this is using the definite integral and motion.